Today, we are diving into probably the single biggest mystery in all of science, dark energy. Seriously, this is a force that decides the ultimate fate of everything. And as we're about to see, everything we thought we knew about it might be changing as we speak.
Okay, let's just jump right in, because this right here, this is genuinely shocking. Everything we see and touch, you, me, every star, every galaxy, all of it makes up just 5% of the universe. The rest is a total mystery. About 27% is dark matter, but the undisputed heavyweight champion, taking up a whopping 68% of everything, is dark energy.
I mean, just let that sink in for a second. 95%. The vast, overwhelming majority of reality is made of stuff we can't see, we can't detect, and we barely comprehend. It's the ultimate cosmic puzzle, and dark energy is the biggest, weirdest piece.
So it's super important we get this straight, because people mix them up all the time. Think of dark matter as the universe's invisible scaffolding. It clumps up, and its gravity is what pulls galaxies together and builds that massive cosmic web. But dark energy, it's the total opposite. It's this smooth, repulsive force, like an engine that's constantly actively pushing space itself apart. One pulls, the other pushes.
And this brings us to the moment where the story really gets wild. For most of the 20th century, scientists were pretty confident they knew how the universe should be behaving. But then, in 1998, they saw something that just, well, it broke all the rules.
The logic was pretty simple, right? After the Big Bang, the universe is expanding. But all the stuff in the universe should be pulling on each other with gravity, acting like a brake, slowing that whole expansion down. But what we actually found in 1998 was the complete opposite. The expansion of the universe isn't slowing down at all. It's speeding up. It's running away from us.
So how in the world do we figure that out? Well, meet the hero of our story, the Type As supernova. These are really special exploding stars that, for complicated reasons, always blow up with the same intrinsic brightness. We call them standard candles. This is huge, because it means if you see one that looks kind of dim, you know it has to be incredibly, incredibly far away. So when astronomers pointed their telescopes way out into the distant cosmos, they found these supernovae, and they were dimmer than they had any right to be. They were just too faint. That could only mean one thing. They were way farther away than any of our models predicted. The only way that could happen is if the universe's expansion has been speeding up over billions of years. Okay, so what could possibly be powerful enough to overpower the gravity of the entire cosmos and hit the accelerator? Well, the prime suspect had actually been hiding in plain sight for over 80 years, buried in an equation written by none other than Albert Einstein himself. The story of this idea is just so dramatic. Back in 1917, Einstein threw in this cosmological constant to his equations. It was basically a mathematical fudge factor to make his model of the universe hold still. Then, when Hubble proved the universe was expanding, Einstein tossed it out. But then, fast forward to 1998, and this thing comes roaring back from the dead. It was the perfect mathematical fit for whatever mysterious force was pushing space apart. Einstein apparently called this constant his greatest blunder. Isn't it just incredible that this supposed mistake might actually turn out to be the single most dominant force in the entire cosmos? So, this brings us to the leading theory. The cosmological constant, also known as lambda, basically says that dark energy is just the energy of empty space itself, the energy of the vacuum, a constant, unyielding pressure that never, ever changes, just forever pushing the universe to expand faster and faster. But there is a huge, catastrophic problem. Our best theory of the super small quantum physics tells us that empty space isn't empty at all. It's this fizzing, bubbling sea of virtual particles just popping in and out of existence. Well, all that activity should have energy. The problem is, when you add it all up, the amount of energy theory predicts is, well, it's just mind-bogglingly huge. It's not just a little off. It's wrong by a 1 with 120 zeros after it. This is, and I am not exaggerating, the single worst prediction in the history of science. For about 25 years, we've just had to live with that insane tension. The theory kind of works, but it makes no sense. But now, brand new evidence is coming in that suggests our prime suspect, the cosmological constant, might actually be innocent. The story is taking a massive twist. And that twist is coming from this absolutely incredible instrument called DAISY. Get this. It uses 5,000 little robotic eyes to measure the exact positions of tens of millions of galaxies. It's building the most detailed 3D map of the universe ever made, and its very first findings are shaking cosmology to its core.
So, to understand what DC found, you just need to know about one crucial number. It's called the equation of state, or simply W. Think of it as a dial that describes how dark energy behaves. Now, if dark energy really is Einstein's unchangeable constant, then W has to equal exactly -1. No wiggle room.
This is the billion-dollar question, isn't it? What if dark energy isn't constant? What if it actually changes over cosmic time? Because that is exactly what the new data is starting to hint at.
And what's so cool here is you can literally see the evidence building. In science, we measure our confidence in a result using something called sigma. A 5 sigma result is the gold standard for a confirmed discovery. So, with its first year of data, DESI saw a hint at 2.5 sigma. Interesting, but not conclusive. By its second year, that hint grew to 3.9 sigma. Now, that's not a discovery yet, but you can't deny the trend. Something is going on. And this is the jaw-dropping implication. All this data, when you put it together, suggests that dark energy is not constant. It seems like it was actually stronger in the past and is getting weaker today. And if that's true, it would mean that the accelerating expansion of our universe is now slowing down.
Now look, this is not just some academic debate for physicists. The behavior of dark energy, that little number W, directly controls the ultimate fate of our entire universe. So let's look at the possibilities.
For a long time, the leading theory was the Big Freeze. That's where a constant dark energy just pushes everything apart forever until the cosmos is a cold, dark, empty wasteland. But this new data, suggesting that dark energy might be weakening, puts a third wild option back on the table: the Big Crunch. In that scenario, gravity could eventually win the cosmic tug-of-war, and the whole universe would collapse back in on itself. And this just shows you how radical this new evidence is. A scenario that was considered total science fiction just a couple of years ago is now a serious possibility, being debated by top scientists. The future of the entire cosmos is suddenly up for grabs again.
So this is where we are, living in this extraordinary moment in science. The data is still pouring in, the mystery is getting deeper, and the very fate of our universe is hanging in the balance. Is it destined to expand into an icy darkness, or will it all come crashing back together in the end? For the first time in a generation, we can honestly say we don't know the answer.